Waves can come in two forms. There are pulse waves, which look like this. A single pulse travels through a medium. And there are periodic waves, which look like this. Something makes a regular pattern with ups and downs in it, and its motion is tracked. One wave follows another. Every wave shares common features. The top of a wave is called a crest. The bottom of a wave is called a trough. The wave goes through a 0 point that you can call the equilibrium point. Amplitude is how big a wave is. It's measured from the middle to the highest point or from the middle to the lowest point. The amplitude of the common sine or cosine wave is 1. It's 1 unit from the central axis up and 1 unit down. If you want to find the amplitude of a real wave, the first thing you have to do is identify the central axis and draw it in. I've shot for middle here on the red wave, but apparently I'm a little low and I will have to try again. Again, if I want to find the amplitude of the red wave, I'm going to have to find the exact middle. There is our 0 line, and the red wave appears to be a regular sine wave with an amplitude of 1. It goes 1 up and 1 down. The blue wave has an amplitude of 1.5. Another way you can find this is to go from top to bottom, that's 3 units, and cut it in half. In the middle, half of 3 is 1.5. 1.5 from top to center, and 1.5 from bottom to center. Wavelength is exactly what it says on the can, the distance from crest to crest, the length of the wave. You can also measure wavelength from trough to trough or anywhere else that's easy to see. It's best, however, not to measure wavelength from center to center, because if you try, you may end up going from one center to the other center, which is only half a wave. Contrary to what your math teacher told you, time period or period cannot be shown on a graph. Your math teacher will say that the period is the distance between here and here, but period isn't a distance at all. It's a time. It's the time that it takes for one wave to come in. The period you're going to need to watch as the wave moves by. 1 1,000, 2 1,000, 3 1,000, 4 1,000. Count off and see how long it takes each wave to come in. On my clock, 1 1,000, 2 1,000, 3 1,000. This wave has a period of 3 seconds. It's 3 seconds from crest to crest, even though from crest to crest is 5 units of wave length. You can see the different periods clocked off on the cycles here for this electromagnetic wave, and you can see them here with these ocean waves. Again, it takes about 1 wave every 3 seconds or so to find the period. In this case, the period is so slow that it's easier to count for 10 seconds and see how many waves come by in those 10 seconds. Or go to another beach where the waves come in more quickly. 1, 2, 3, 4. These seem to have a period of a little less than 1 second. Frequency is the number of waves per second. If we count for 1 second, how many crests will we see go by? My count for these waves is about 2. Let's try it for 10 seconds and see how many crests go by. 1, 2, 3, 4, 5, 6, 7, 8. It's all right. I get about 8. That means we have 8 crests in 10 seconds. That's a frequency of 0.8 crests per second. So we were right when we said it was about 1. Time period, or just period for short, and frequency are reciprocals. If it's 8 crests in 10 seconds, that's 10 seconds for 8 crests. That's a period of 1.2 seconds. Speed is related to the length of the wave and how quickly the waves are coming in. These ocean waves are slow because they're very wide and they're coming in at a very low frequency. Wave speed also depends on the medium. I'll say that again because it's the most important thing we can remember about wave speed. Wave speed depends on the medium. If you're a water wave, you'll travel very differently through the water than you would through the sand or through the ground, where we would call you a seismic wave or an earthquake wave. If you're a sound wave, you'll also travel differently through the water, through the ground, and through the air. Wave speed is directly proportional to wavelength, lambda, and to frequency,